Bismillahirrahmanirrahim. Welcome to lecture number 14. We will continue our discussion on plotting in Python. This is the discussion agenda. In last lecture we saw different types of plots. We will explore more functions in Python and how to create box and whisker plots. We will see how to create heat maps. We will understand animations in Matplotlib. We will understand interactivity in diagrams. Then there will be assignment number 6. And the last topic we will see how to visualize data in Pandas library. So let's go to our Jupyter notebook and see how to create these different types of plots. So let me make it a little bigger. So we are going to continue our discussion about box and whisker plots. So a box plot, sometimes called a box and a whisker plot, is a method of showing aggregate statistics of various samples in a concise manner. The box plot simultaneously shows for each sample the median of each value, the minimum and maximum of the samples, and the interquartile range. So the first thing we need to do is to import pandas as PD. Then we will have a normal distribution. So normal sample is equal to np.random.normal with the location 0.0, scale is 1.0, and size is 10,000. We have a random sample, so np.random.random, size is 10,000, and we have a gamma sample, np.random.gamma to size 10,000. Now we create a data frame, so pd.dataframe, normal distribution with a normal sample. We just give them labels, random with a random sample and gamma with a gamma sample, and we give it a name df. So let's try to execute the code. np is not defined, so we can import it because it was imported previously. So import numpy as np. And nothing happens because we have not performed any print operation. So we can do df.describe, and you see this is our normal data, this is our random data, this is our gamma data, and each has 10,000 samples. This is the mean value of all, this is the standard deviation, the minimum, the 25%, 50%, 75%, and max. So we create plot.figure and we create a box plot of the normal data and assign the output to a variable to suppress output. So we do plot.boxplot and we give it data frame normal and viz is range. So we just give it a variable name, it's not important. Plot is not defined, so we need to import it. So import matplotlib.pyplot as plt, and I think it's not displayed because we have not enabled this one. So we can do like this. Let's go back to our code. Yes, so this is how the box plot, or simply box and whisker plot, is displayed. This shows the mean and this shows the minimum and the maximum and minimum, and the standard deviation. Now we can color the current figure by saying plot.clf, and we can plot box plot for all the three of df's column. So we have plot.boxplot, df normal, df random, df gamma, and viz is range, and we just assign it to a variable. And you see this is for normal distribution, this is for random distribution, and this is for comma distribution. And for comma, the difference between minimum and the mean point is very long, and you will understand in a while. So let's try to create a new figure, and plot.hist df gamma, because gamma has a weird shape, so we want to know how the data actually looks like. And you see this is the minimum point is here and the max is somewhere here, so that's why you have a long tail until the max. Now let's see some more information. So we import mpl underscore toolkits.access grid1 insert locator as mpl.il. We have plot.figure, plot.boxplot, normal distribution, random distribution, gamma distribution, and basis range, and we overlay axis on the top of another. So x2 mpl.l.insert axis plot.gca, width is 60%, height is 40%, location is 2, and ax2.histogram df gamma, base is 100, and ax2.margin x. So it will give some information to the, so you see this is the this plot, so we have added this plot to this one. We can switch the y-axis ticks for ax2 to the right side by saying ax2.ytick xticks.right. You see the ticks are coming this side instead of this one because it was overlapping with the previous one. And if viz argument isn't passed, boxplot defaults to showing 1.5 multiplied by interquartile, whisker with outlier. So we can do plot.figure, boxplot, normal, random, and gamma. And you see it's just trailing values. It's trailing values beginning and end. There is no trailing value, and it has log. So that was box plot. There is another type of plot that's called heat maps. So in Matplotlib, heat map is simply a two-dimensional histogram with x and y values, and that indicates potential points, and the color plotted is the frequency of the observation. So let's create a new figure, plot.figure, and we create a distribution, normal distribution. So np.random.normal, and then we have another random distribution dot random, plot dot his two-dimensional xy, and number of bins is 25, and plot.figure, first let's plot this one, two-dimensional histogram. Yeah, so it's the heat map of the two-dimensional. So you see there are around 25 bins per column, and all the columns show the relevance between the rows and the columns. So it's the relevance between normal and random distribution, and in the middle they are basically the height. Well, there need to be, if we can increase the bin and see, it looks like that scatter plot that we have created. we can add a color bar legend. So plot.color bar, and it's a function. So it shows the intensity of the, so 0 means there is no correlation, and the high value, the 10 value, means that they are highly correlated. So that's how you can create heat map. You can explore further and see how to create heat maps for different data sets. The next thing is animations. So Matplotlib has built-in capabilities for animations. So import matplotlib.animation as animation, n is equal to 1000, np.random.rand n with the number n, so that's x, and we create a function that will do the plotting when CURR is the current frame. So def update current, check if animation is the last frame, if so stop the animation. So if current is equal to n, a.event source dot stop, and otherwise we continue. Plot.cla, number of bins np.range minus 44.5, plot.histogram x colon cur bins is equal to bins, plot.x is minus 44030, plot.gca.set title and y label and x label, and we can annotate for the n that will print this information in the graph. So nothing happens because we have not called the function yet. So we can create a new figure. Figure is equal to plot.figure, and animation.funcAnimation. That's the function that is used for animation. We have a figure, that is this one, update, that is calling this function, and interval is 100 milliseconds. So you see, this is how for different number of bins, you can see here how the histogram is created. So this is just one sample code. Try to play with the code and try to create different animation in the Matplotlib. Now there is another component in Matplotlib that allows you to interact with the figure, with the plots. So let's create a new one, plot.figure. Data is np.random.rand and plot.plotData, and we simulate like the on-click event. I think you already know how to read the on-click event. And then plot.clear and plot.plotData and plot.gca.setTitle. And then this is something that we are displaying: event.x, event.y, event.xData, event.ydata. And tell MPL Connect we want to pass a button press event into onClick when the event is detected. Plot.gcf.canvas.mpl Connect button press event onClick. You see? So event at pixel this one, and data this one. If I click on this one, so this is the X and Y, and this is the data at this one. I can click anywhere and I can get the data. So this is how we can interact with images. Let's see another example. So from random we import shuffle, and let's say we have country names like origin, China, Brazil, India, USA, Canada, UK, Germany, Iraq, Chile, and Mexico, and we shuffle the origins, and then we create a data frame, pd.dataframe, height, np.random.rand 100, weight np.random.range 100, and origin is this origins, and we print the df. So this is the data, the height and the width and the origin. Then we create a plot.figure, and figure is equal to 5 means the mouse does not have to click directly on an event, but can be up to 5 pixels away. So plot.scatter df height and df weight.figure is equal to 5, and plot.gca set y label width, and plot.gca.set x label height. So let's say if we click on this one, I don't know why it is not displayed. Maybe we did not. Yes, we just plotted. Okay, so let's try to add event. So on pick event, this is a function. Origin is equal to df.ilog event.index0 origin, and plot.gca.setTitle. Selected item came from format.origin, format parenthesis origin, and we tell MPL connect we want to pass a pick event into onPick when the event is detected. Plot.gcf canvas.mpl connect pick event on click. Now let's execute this one, and then we come back for the image, and you see if I click on this, you see selected item came from UK. This is another country, this is another country, this is from another country, and so on. So you can make interaction with the image like this. So that was interactivity, and we have an assignment on this one. So let's go through the assignment. This is assignment number 6. It's about building a custom visualization. So different options are given below, and by the way, you can read this paper in order to understand more about the assignment. And this figure, I don't know why it is not displaying, but it should display on your computer, these figures. And then so try to understand the assignment, what is required, and then the solution is given below. So you can execute this code, and eventually you will have a plot like this. But try to write code yourself and try to compare your solution with the solution that is provided to you. Okay, so that was the topic that we have to cover, but there is some more data, some more information that we need to cover, and that's one is how to display from pandas, and the other one is how to display using Seaborn, and how to create 3D images. So let's do the pandas visualization. Let me clear all the outputs. So let's make sure that we have. So this is the matplotlib pandas and Seaborn. Yes. Okay. So first we import pandas. So import pandas as PD, import numpy as np, and import matplotlib dot pyplot as plot, and we do this matplotlib notebook and person to make sure that browser is able to display our plots. We can see the predefined style provided, so plot.style.available. So it's Seaborn dark, Seaborn dark red, and then many others are provided. So let's say we use Seaborn colorblind. style. So plot.style.use seaborn color blind. Now we have np.random.seed123, and we have pd.dataframe a. A is np.random.rand 365.custom0. B np.random.rand 365.custom0 plus 23 np.random.rand 365.custom minus 20, and index is pd.daterange 11/2017 periods 365, and we can print the df.head. So for different dates 1 2 3 different dates, there are some data in the A column and in the B column and in the C column. We can do the df.plot. Okay, so this shows the different data. This is January, February, March up to December for different months, and this is some data. This is for C, is high in January and decreasing. For B is somewhere here, and for C, this is for A, and this is for B. So we can select which plot we want to use by passing it into the kind parameter. So df.plot AB kind is equal to scatter. So this is the scatter plot for A and B. You can also choose the plot kind by using dataframe.plot.kind method instead of providing the kind keyword argument. So kind can be line plot, that is by default, bar plot, bar horizontal, histogram, box plot, KDE, density, area, pie, scatter, and hex bin. We can create a scatter plot of column A and C with changing colors and size based on the column B. So we have df.plot.scatter A, C with the color is equal to B, and S is equal to dfB, and color map is equal to, this is just one type of color map. So you see how the data from different classes are used. So the colors are used from the B, and we are using data A and C. Now we have AX df.plot.scatter, A and C color is from B, and S is dfB color map the same, and set aspect is equal to equal, because this aspect is different, so we can see this aspect ratio is the same because this one is stretched, so we keep the same aspect ratio. We can do df.plot.box to create the box plot, and df.plot.histogram with the alpha value of 0.7. So this is for different ABC. df.plot.kde, it will show the KDE figure. This is the density function. This is for class C, this is for class A, this is for class B. And we have pandas.tools.plotting. So let's say we import iris dataset. Iris dataset is a very famous dataset. You can search on internet and try to understand this iris dataset. So it will pd.3._csv iris.csv, and then we say iris.head. I think the iris dataset is not downloaded. Let me search the okay, iris dataset is not downloaded. That's why we cannot load the data. But try to download the iris dataset and try to display it. So you will see this different plotting. So pdf.tools plotting parallel coordinates, iris dataset and name. You can download iris.csv data and then execute this code. It will show you this plot. So the last topic that we have to cover today is Seaborn. Seaborn is another library that is used for visualization. So we import NumPy as NP, Pandas as PD, and Matplotlib as PyPlot as PLT. Import Seaborn as SNS and Matplotlib notebook. So we create two random distribution, np.random.seed 1 2 3 4, just some value, and pd.series np.random.normal distribution 0 10 1000 and name is v1, pd.series 2 multiplied by v1 plus np.random.normal 60 15 and 1000 and name is v2. So these are two data set, and then we print the histogram. So plot.figure, plot.histogram v1, alpha value 0.7, number of bins and label is v1, and plot.histogram v2, alpha value 0.7, bins and label is equal to 0.2, and we can print the legend. So this is the distribution. This is v1 distribution and this is v2 distribution, and we have given this one is normal distribution and the other one is normal distribution, but it is v1 multiplied by 2. Now we plot a kernel density estimation over a state bar chart. So plot.figure, plot.histogram v1 v2, his type bar staked, normal distribution is true, and v3 is equal to np.concatenate v1 and v2, and sns.kde plot v3. Now let's see how SNS is used to create KDE plot. So this is the density estimation function. Now we have plot.figure, and we can pass the keyword argument for each individual component of the plot. So sns.distribution plot v3, and histogram color is equal to color, and teal, this is another type, and KDE color is navy. So this is how SNS is used to plot density plot. We can use SNS to print join plot. So v1 v2 alpha value is 0.4, and you see how the plot is created with this one. And we can have the set aspect, that is set to equal, and we can have kind as the hex, so this is hexagon, and we can have sns.setStyle and sns.joinPlot v1 v2. Kind is KDE, space is 0. So you see this is a different type of diagram that you can create in SNS or Seaborn. This is again used for iris dataset, but I'm not going to execute because we do not have the iris dataset. But you can execute the code for yourself and try to understand how this pair plot from Seaborn is used to display the data. There is also the swarm plot. So try to see the code and you can see some beautiful visualization of the code. I think we should stop it here. Thank you very much.